For today's webinar, we will look at ensuring new equipment is user-friendly. Our presenter today is Ross Kennedy. Ross is the President and Founder of CTPM. He is recognised as Australasia's leading authority on total productive maintenance and CTPM's operations excellence through the TPM and Lean methodology. So let's get started. We hope you enjoyed today's webinar, and I will now pass you over to Ross.
And welcome to our webinar. This month we're talking about ensuring new equipment is user-friendly. And as you can see there, the four areas we want to focus on is why user-friendly is as important as functionality, having the right team that understands standardisation, trainability, operability and maintainability, using checklists to capture experience and learning, and developing the right training for your people. So I thought I'd start with just an outline of what we often find happens at sites when they decide to go and get new equipment. The senior management often makes the decision that the new equipment is required. Project engineering is given the task to scope out the work and arrange any contract required. Purchasing is given a bill of material and requested to buy the new equipment not supplied by the contractor. Purchasing is given equipment arrives and is installed, and then project engineering arranges for commissioning and hands it over to production. So 5 pretty basic steps, and I'm sure there's a lot in between, but it seems to be the traditional way most people approach it. Unfortunately, what we hear a lot of stories about is that things don't quite work the way as expected, so maintenance get called when it doesn't work. Production and maintenance then battle to get the new equipment to perform as expected, and then project engineering don't want to know about any problems because they're busy with the next project. So I thought I'd just start the webinar off with a simple question about, does anyone have that experience in their workplace? So does your site follow this traditional approach to new equipment, and hence create frustrations for your production and maintenance people? So we're just looking to see whether this happens most of the time when you get new equipment, only sometimes, rarely as we get everyone engaged from the very start, or maybe you're just not involved in new equipment at your site. So we'll just a quick look at the poll, and so what we find is that where our poll is just about finished, we've got some people here who have this happening most of the time. We've got 25% there, about 50% of you about sometimes, and 25% rarely as we engage our people. So it's good to see that there's some people out there engaging. Hopefully we can help you to engage a little bit better, and for those who have this traditional approach, hopefully we can share some learnings with you. So the first point was why user-friendly is important as functionality. What we've found is engineers traditionally look at functionality, in other words, how does the machine work, what's it supposed to do, as the prime objective of design, and often pay limited attention to standardisation, trainability, operability and maintainability, which all impact on the user-friendliness of the equipment. What we mean by standardisation, I think you'll understand, is just having, how do we get standardised componentry, standardised ways with the new equipment that we currently use in the organisation. Trainability is how to make it easy to train people, operability, how easy to operate, and obviously maintainability, how easy to maintain. When we talk about user-friendly, it's basically saying that we want the equipment easy to train people on, easy to operate, easy to identify defects, whether that be equipment defects or product defects, easy to monitor the condition of the equipment, and easy to maintain it. The other thing we find in a lot of situations is that the procurement process. Procurement traditionally look at price as the prime objective of selecting suppliers and often pay limited attention to life cycle cost, which is impacted by standardisation, trainability, operability and maintainability. And life cycle cost is looking at the total cost of this equipment to the business for the expected life of the machine. So you might be buying a new piece of equipment you're going to have for 5 years. Well, all the costs associated with not only operating the machine but also maintaining the machine, doing changeovers on the machine, etc., need to be factored into what's this machine costing us, not just the purchase price. So again, it's about user-friendly. Now, I remember years ago I was at actually I was at a mine site in Queensland, and the people there had been to some of our training previously, and they were in the process of getting a new lubrication truck, which is a very important vehicle that goes out and services all the mobile fleets. And they put a team together, and they'd gone through and looked at what they had and came up with some really good innovative design changes and requirements to make it much more effective. And while I was visiting the site, this new truck was due to arrive, and it turned up, and much to the horror of everyone, it was just like the old one they had before. And the mine manager got on the phone very quickly to the central procurement people, and the answer was, well, this is what we've always bought, and it's the cheapest one, so that's why we bought it, and we just threw your specification away. Consequently, there was a lot of unhappy people at the site. So getting procurement on board is also very, very important in this whole process. So just talking about user-friendly examples. When we talk about standardisation, what are some of the things we want to standardise? And I've listed out here a number, and this is just a very short list, but gives you a bit of an idea of some of the things. And sometimes you might look at this saying it's getting into too much detail. Things like whether we have metric or imperial threads on our fasteners. Tell that to a maintenance person who has to carry special spanners, and they'll see it is very important. Just the way we have the head type slots, sizes, why we have so many different sizes of nuts and bolts, the way our locking mechanisms. This is getting into a fair bit of detail, but again, these are the little things that can really get rid of the frustrations if we get them right. And the cost of asking for a fastener to be a set way in the design phase is there is no cost when you make the machine to have it the way you want it. So you then have pneumatic controls, their service units, even gauges on pneumatics. If we want our operators to walk past a gauge and tell whether we're in operating range or not, we want the gauge very easy and visible to see. And again, I've seen many new equipments come in where gauges are placed either in awkward situations or a very small design that are very hard to read from a distance. Hydraulics, motors, electrics, transmissions. So there's a lot of things we can standardise. Trainability. We want it easy to understand, and we want comprehensive isolation procedures, pre-start checks, standard operating procedures, work instructions, job breakdown sheets, standardised worksheets, performance reporting, how do we report the performance of the equipment, handover procedures to the next shift. Again, there's a listing of things that you can add to that. When we get to operability, defining user-friendly operability, the way we define is we want so that operators to identify process and quality problems at the earliest possible time. So we want to make it really easy for operators to identify problems at the earliest possible time. We want operators to identify equipment defects at the earliest possible time. And we want operators to conduct setups and changeovers in the shortest period of time. And this is all about TPM and Lean, about best practice. And what we expect from our people, we've got to make the equipment so it's easy for them to do this. What we're trying to do is make it easy to do right and difficult to do wrong for our operators. So again, we can have a listing of things we look for user-friendliness in operability. And again, easy to isolate, easy to operate, easy to identify defects, easy to access for cleaning. In other words, have the equipment off the floor, easy visibility to see conditions of key components, easy to access for inspecting, easy to identify conditions that could lead to quality problems, etc. So again, it's creating that listing of all the things to think about as you go down the path of getting new equipment. Maintainability, an example listing here, is easy to access for servicing, easy to diagnose problems. You want built-in diagnostics on modern equipment. You think about the most sophisticated equipment in your office, it's probably the photocopier, but yet it is very easy to operate because if anything goes wrong, you get very clear instructions on what to open, what to close, what to press, when to call a service person, etc. That's what we call good diagnostics on our equipment. Easy to monitor conditions while running. We want to have minimum planned downtime, so how do we make sure we've got good components on the equipment? And the exchange out of wear parts and rotables. The equipment has parts that wear. They have parts that you rotate in and out, like cylinders and motors and gearboxes, etc. Now, if you want to link that into your operator equipment management clean for inspection activities, you want all these tasks of maintenance tasks to be done in a short period. Ideally, nothing to take longer than an hour to repair on the machine. So that's all part of design and specification. Then you can do all your maintenance work while the operators are doing their clean for inspections. Obviously, we want excellent documentation, and the tagging of equipment as into identifying equipment and components on equipment, so that if there's a problem, the operators can easily explain what it is that is causing the problem to the maintenance people before they're called, or as they're called, I should say. Just as a simple example of user-friendly visual controls. On this piece of equipment, instead of having a metal covering all over the transmissions or the drive chains, they've taken or cut the metal out and put a Perspex cover in there so you can easily see inside with appropriate lighting, and they're painted behind the chain so that an operator or anyone walking past, if they see the chain is in the red area, it is time to call the service person or maintenance person to come and make the adjustment. Now, the alternate approach is to have that fully covered in metal. No one sees the chain, no one sees that the chains are starting to get extended or need tensioning, and typically the only time you find out about it is when you hear a horrible noise or you start hearing noises, and then by that time more than likely the sprocket's damaged, the chain's damaged, and you're up for expensive repairs. So again, very simple, very visible, and easy for operators to see as they walk past. So the next point is having the right team that understands these things: standardization, trainability, operability, and maintainability. Now, just talking about teams and new equipment management, we've identified there's 5 stages to new equipment management. There's the design stage, procure stage, acceptance stage, install and commission stage, and then the perform, monitoring, and learn stage to learn and reflect on, did we get it right with our new equipment or not, and if we didn't, how do we change our check sheets or our lists so that when we bring in new equipment again, we do it better. So the idea is that we want to do that performance monitoring and capture that learning and feed it back into the process. So there's 5 stages, and what we've learned is with teams is that a team should only have about a maximum of about 12-week life. And sometimes when you're getting new equipment, it can be a lot longer than 12 weeks. It could even be 6 months from the time you procure to the time it actually arrives on your doorstep. So what we find often, rather than have one team that goes on and on and on, you probably have a team to do design and then hand it over to a team that goes and does procurement. And there could be some common people in those teams, but they're refreshed as a new mandate, new purpose. If I break these teams down into a bit more detail, we have developed training material or support material for teams, team member manuals for, and for stage one we have what we call macro if we're going to put in, say, a new bottling line, a whole new plant, or a micro new equipment management design team if we're going to put in, say, a new filler for an existing bottling line. We have a special micro procurement team to identify and get the procurement process right. We have a special micro compliance testing team. We have a special micro new equipment install and commission team. So again, and sometimes one team can do the whole lot, other times it's a big project, you can break it down. So again, dividing it down into specific areas so we can get very good management of the process. The launch, post-launch is normally done with your continuous improvement teams such as work area management, operator equipment management, area-based teams, and your focused equipment and process improvement cross-functional teams, feeding back into the knowledge base on new equipment that you are developing. So typical team members, 4 to 8, who should be in the teams. Depending on what stage you're at, you would probably want people from project engineering, production, maintenance, quality, training and procurement involved. And the most important thing about that is you need to ensure some members in the team, it doesn't have to be all of them, but at least some of them, have TPM and Lean implementation experience, especially operator equipment management steps 1 to 5. Just to refresh you, step 1 is about being able to find defects. So how do you make it easy for people to find defects unless you've actually been out and doing it? You probably don't pick up on some of the things that can be done in that area. We get into OEM2, how do you make it easy to stop contamination and control contamination on the equipment. Stage 3 is about lubrication, so how do you get perfect lubrication and manage the lubrication and make it easy to identify lubrication problems. And step 4 is about the functioning of equipment, so how do we make sure we are getting equipment and support manuals and logs and information to be easy to train operators in the functioning of the equipment. So they're some of the things we want to have that knowledge or experience in our teams. Now, checklists. I've been giving you sort of listing of information about operability, maintainability, etc. The idea is to create your checklists at your own site for your site situation, and you keep building on these checklists as you get more and more experience, and you use them when you approach new equipment to make sure, yeah, have we considered, have we thought of, is this required, is this not required? And we find checklists a very, very useful tool for new equipment management. And this is just an example. It doesn't have to be a complex document. All you need is what it is that you're trying to look for, and is this relevant or required, and any comments. So leading on to the fourth point we wanted to touch on, developing the right training. What concepts do we need to have people understand if they're going to be on these teams, and to get new equipment management working for them? Obviously user-friendly, which we've talked about, so I won't touch on that anymore. But there's a couple other concepts: prevention at source design, compliance testing by competent people, and life cycle costing. So prevention at source, finding problems at the earliest possible time. We learned back in the early days of the quality movement, probably especially spearheaded by people like Dr. Edward Stemming, taught us that if we can find the problems at the earliest possible time, it is a lot cheaper and easier to fix than if we find them at the end of the process or end of the value stream. So for example, if we find our raw materials not correct when we're going to make something and we reject it and not use it, it hasn't really cost us anything except maybe the cost of the raw material. if we go and process that raw material and then find we have a problem, it's going to be a lot more expensive to us, and if we give it to our customer, it becomes extremely more expensive. So prevention at source design is recognizing that let's try to pick up on the issues at the earliest possible point in time. So prevention at source design involves getting all affected parties involved at the earliest possible time to use their collective experience to create a detailed design specification. And unfortunately, what happens in a lot of situations is that people don't invest that much time in the design, and they then spend a lot of time reworking things down the track. And the smart companies put the effort in and the time up front in the design and making sure everything is correct, so that then once you start building prototypes or building the equipment and then operating the equipment, you don't have the big problems. And there's many good examples of that, case studies of where people traditionally put small amount of time into the design and spend a lot of time on rework and getting the thing to work properly, as opposed to investing the time up front in the process. So that's prevention at source. The other issues are compliance testing by competent people. So there's two types of compliance testing, one at the manufacturer's premises, the other immediately after it arrives at your site. At the premises, does the equipment comply to the detailed specification for functionality, operability, maintainability, standardisation, trainability, etc.? So does it really comply? And then once it arrives at your site, has the transporting the new equipment caused any problems? Has everything arrived that should have been arrived? So you need to make sure you do it at both places, and most importantly, the people who will operate and maintain the equipment should also be involved in the compliance testing. It's not just sending over the production manager or the project engineer to check on the equipment. The best people to do it are the people who are going to be operating it and maintaining it. And the last point is about lifecycle costing. When we talk about equipment-focused TPM, uses overall equipment effectiveness as a driver for improvement. Process-focused lean uses lead time reduction as a driver for improvement. Well, the most effective driver for new equipment management is what we call lifecycle cost, and that is the total cost from inception to disposal of the equipment. So by evaluating each option for the new equipment based on its impact on lifecycle cost, the team can evaluate based on long-term thinking supported by facts and data rather than short-term cheap options that may cost considerably more over the life of the equipment. So in other words, you're going to buy a new piece of equipment. You might say, we want this machine to run for 5 years. Then we look at, okay, what are the options we have on the equipment, and what's the impact on the life cycle cost? The life cycle cost includes operations, maintenance, even up to the point of disposal. But simple things like changeovers. How many changeovers do we expect to do in 50 years? And is it worth spending an extra $20,000 on an attachment that will reduce the changeover time by half or not? And if you calculate out how many changeovers you expect to do, you can calculate the savings you'll get by that initial spending more. So it's about what's the total cost of the business for the life. That should determine our decision making on a lot of the design parameters that we put into our equipment. So just as a final word, new equipment management through a series of cross-functional teams allows you to apply TPM and lean experience to new equipment designs and installations so as to minimize lifecycle cost while creating a user-friendly workplace. A key part of new equipment management is prevention at source design activities so as to minimize start-up problems and costs. Hopefully you found this to be of some benefit, to give you a bit of a understanding about new equipment. Now, as Nelson said earlier, how can we help you to develop your in-house capability? We've just been in the process of launching our new CI Community of Australasia membership, where it's an opportunity to become part of this CI community we're trying to create. We've got a lot of experience here at CTPM, and we want to try to share that with everyone. So we're asking people just to join as a part of our CI community, and there's a lot of benefits there for doing that. And it's sort of demonstrating you're keen to learn by sharing with other people. And it gives you access to our knowledge just by simply asking or sending an email. We can answer your questions, and especially if you've got any ones on your management. More particular, we've got some workshops coming up, which Nelson spoke about, which is our 2-day workshop in Sydney, and we're also running a 1-day workshop on getting new equipment right the first time, where we'll give you a lot more examples and go into a lot more depth than what we can do in a little short webinar. And with that, I'd like to hand over to any questions, please.
Thank you, Ross. We'll now have any question time for the last question. So if anyone wants to raise their hand, so voice Ross a question, or simply type in the question box provided. We have one question here for you, Ross. How do you set the time frame for establishing a life cycle cost model for new equipment?
That's a good one. This is a bit of the looking into the crystal ball as to when we bring in a new equipment, how long do we expect it to run for? And I guess some of us have probably got equipment in our plant that we thought we'd only have for 5 years, and 25 years later it's still there. It's just got to be a business decision made on, okay, we're going to bring this equipment into a certain product in a certain market, and we will pick a time frame, and it might just be as simple as 5 years, 7 years. Again, I wouldn't get really heavily paranoid about it. It's just getting consensus agreement. Okay, for the basis of our design, let's work on a time frame.
Okay, no worries. Doesn't seem like we have any more questions. So with that, thank you everyone for attending. Just a reminder that our next CTPM webinar will be scheduled for Tuesday the 19th of May, and it's about holistic approach to setup time reduction. If you have any questions, please feel free to contact us at any times, or you require any more information. Thank you everyone attending again. Thank you, Ross, for presenting the webinar. We hope you enjoy the rest of your week, and we hope to see you at our next webinar. Thank you.